Welcome to today's class. Today's class is on chemical bonding and it is hybridization trick and shape and isostructures. This class is full of trick and it is very important for entrance and class point of view. Entrance, neet, JEE, IIT, etc. All types of higher exams. The question very often asked in this topic. So you just minutely follow the trick, nothing else. You can't keep all these things in your mind until unless you have some trick. So hybridization, how to find out hybridization, along with you need to find out the shapes and isostructural compound. So before starting hybridization, let me tell you that the common type of hybridization very often you will come across in my discussion, and don't be confused. This is very simple and important trick I will going to explain here. So before starting sp3, sp2, spd, sp2, sp3d, sp3d2 and sp3d3, let me give you some knowledge about hybridization of organic compound. First, you see, if there is single bond, you assume it single. If there is double bond, you assume it single bond. If there is triple bond, you assume it single bond. Means all bond of carbon-carbon should always be assumed as single, no matter whether it is double or triple anything. Let me take one example. Say this, all are single bond. Say chlorine, whatever. If it is chlorine, or in its place, if it is hydrogen, am I right? And if you are asked to find out the hybridations of carbon, I will go a bit fast. So here is single bond. How much single bond are there? 1, 2, 3, 4. 1, 2, 3, 4. 4. 4 means S is always fixed, S always 1, and to make it 4 in unit. Am I right? Now come to this. If we're asked to find out the hybridations of this carbon or that carbon, come to this carbon. Assume 1 bond, 2 bond, and double bond must be 1. Am I right? So 1, 2, and 1, 3. You are getting total 3. So this 3 is equal to S is always constant. This is 2. Now again you come to this. Am I right? So 3 should be always counted as 1. So assume that was the compound. You are asked to find out the hybridization of this one or that one. So for this carbon, bond 3 means 1, 1 means 1. There are 2 bonds. S is always 1. Hybridization is sp. Now come to this carbocation. In higher second year, you will get the definitions, or in first year also you have got this one. In mechanism, you will find this one. This is carbocation. If you are asked to find out the hybridization of this one, you see bond 1, bond 2, bond 3. Plus is not assumed. Bond 3, total bond 3. S is fixed, make it 2. Hybridization is 3. So carbanium. Am I right? So assume the, if you are asked to find out the hybridization of this one, you assume 1 bond, 2 bond, 3 bond, and 1 negative line. 1 negative line, anion minus 1 should be counted as bond. So 1, 2, 3, and 1 negative is equal to 4. Your hybridization is sp3. Come to this one. If we're asked to find out the hybridization of this ketone group carbon, so along this carbon on both sides, double bond, this double bond is equal to 1. This is another, this is another 3. You are getting 3. So 3 is sp2. No problem. You can find out. Say if this is in this way, you are asked to find out the hybridization of this carbon. So this is 1 bond. If asked to find out the hybridization of that carbon, this is 1 bond, and above minus it 2 sp. Let me discuss these things. For sp3 hybridization, 7. The central is attached to the 7. 3, 3, 6 and 7. This is the structure you should know. That is sp3 is octahedral, sp2 is trigonal planar, sp is the linear, dsp2 is the square planar, sp3d is equal to trigonal bipyramidal, sp3d2 is octahedral, sp3d3 is equal to pentagonal bipyramidal. You should know this one, you should learn by heart. But these things all are regular structure. Always these structures are not fixed. If anywhere there is any question of lone pair, a very important thing in my first class of bonding, I told you how to find out the lone pair. If there is any lone pair, there will be distortion. There is some distortion of the shape from this. And if there is distortion of the shape, bonding will change. So lone pair is a very important thing. So let us first take one example. This regular shape, semi-10. How will you find out the configuration? The shape, I told you trick. What is the trick? So always you assume hydrogen is equal to 7 electron. It is exception. And other things, just you assume the valence electron. So carbon is equal to 2, 4, 2, 4. Valence electron, carbon is equal to 2, 4. Valence electron is equal to 4. 1 carbon is equal to 1, 4. And 1 hydrogen is equal to 7. 7, 4 ja 28 equal to 30. Divided by 8. Your answer quotient is equal to bond pair. If any remainder is there, so divide by this electron by 2, you will get number of the lone pair. Say there is 2 electron left, means 1 lone pair. 4 electron left, 2 lone pair. 6 electron left as remainder, then it is lone pair. Means here no lone pair. There is no lone pair. Your answer is bond pair. Your bond pair plus lone pair gives you the hybridization. Lone pair plus bond pair gives you hybridization. Here bond pair is 4, but no remainder is there, is the 4. 4 means what? S is always fixed. Make 4, you need to sp3. This is regular. This is regular. Now case 1. Let me take case 1. Case 1. Very simple. You just don't get nervous. Lone pair is equal to 1 and bond pair is equal to 3. There should be always 4 in case of sp3. The total count lone pair bond pair must be equal to 4 for sp3. Am I right? For the regular there should not be any lone pair, then structure is tetrahedral and 109. And if there is lone pair, then there is some distortion. So if there is, in case of sp3, if there is one lone pair, then it is less than 109.28. Lone pair makes the bond angle different, less than regular bond angle. You should know this one fixed, 109. You should know. So if there is one lone pair, it should be less than 109. It will never be 109. So lone pair is equal to 1 means 109. If lone pair is equal to 2, then it is around 104 or less than this. Further decreases means more the number of lone pair, more is the decrease of bond angle from the regular bond angle. If it is 1, it is less than 19, means it will be around 105 or 106 or 107 like this. Am I right? And if there is 2 lone pair, it will further decrease to 104, 103 like this. Am I right? So bond angle I will discuss later on, because today my concept, my trick is on hybridization in shape and isostructural compound. So I am giving you some idea. If there is one lone pair in sp3 hybridization, that bond angle will never be 109. It is a bit less than 109. If there is 2 lone pair, then it will be around 104. Now, what is the shape? If there is one lone pair, this is trigonal pyramidal. If there is one lone pair, trigonal pyramidal. If there is 2 lone pair, it is band shape. Nothing else. What about the example? I will give you the example. Where there is one lone pair, that should be trigonal pyramidal, and if there is 2 lone pair, that should be band shape. But hybridization is sp3. So lone pair is everything. So let us find out its hybridization. I have shown you how to find out the hybridization, but consider hydrogen is equal to 7 electron. In other case, you just plus the valence electron. So for methane, we have got, it is a regular shape, its bonding, it is a tetraedral structure, bond angle 109.8. and now for lone pair is equal to 1, what happens? Let us take ammonia. Our main concept, we should get total 4 lone pair plus bond pair must be equal to 4 for sp3. 3 and 1, 4. Am I right? 3 and 1, 4. We need to get 4. Now what's happened? You see, in case of ammonia is 2, 5. Am I right? So valence electron is equal to 5 and 1 hydrogen. I have shown you the hydrogen should be 7. So 3 hydrogen is equal to 21 is equal to 26 divided by 8 equal to 3 plus 2. Am I right? So your result is 3 means this is bond pair, and this is 2 electron means 1 lone pair. Am I right? This is the trick. So you have got in 4 lone pair is equal to 1, bond pair is equal to 1. If lone pair is equal to 1, bond pair is equal to 3. Bond pair is equal to 3. Nothing to calculate. 3 plus 1 is equal to 4. You are getting 4 means 3 bond pair, 1 lone pair. Total you are getting 4. 4 means it is again sp3 hybridization. Ammonia is sp3 hybridization, but its structure is not regular tetrahedron. It is less than 108 means it is almost 107. I am not concerned with the bond angle. I am at the shape means it is trigonal pyramidal. So this is one example where 1 lone pair. Now come to sp3 hybridization with lone pair is equal to 2, and I have told you the bond angle will be like this around this, and it should be band shape. Let us take one example of water. Am I right? So example of water, here hydrogen means what? 7 hydrogen means 14, and oxygen means 2, 6. Am I right? So outermost electron is, valence electron is 4. This is equal to 20 divided by 8 is equal to 2 and 4. 2 bond pair, 4 electron is equal to 2 lone pair. Totally you are getting 4 lone pair, bond pair equal to 4. That is equal to sp3 hybridization. Instead we have calculated the bond hybridizations of water is sp3 hybridized, but it's due to presence of 2 lone pair, its bond angle would be around 104 and shape will be band. This is the technique. This is the technique. So these are the two cases in case of sp3 hybridized. One is lone pair 1, other is lone pair 2, and lots of examples are there. I will give. And lots of example, iron sulfate, ClO4, BF4 negative, NH4 positive, HCO4L, Cl4, PH4, each and every one I can't show you, but I am showing you some of this one. So let us, so all cannot be solved out here due to time. So let us take this one, a critical one, ClO4 negative. So here chlorine, fluorine, chlorine, bromine, iodine, it is 17 means 2, 7. Valence electron is 7. 7 plus 7 plus it is 6. 6 into 4, and this will be add, minus will be add up. So 7 plus 24 plus 1. So you are getting 32. 32 divided by 8 is equal to 4. Am I right? So here no remainder is there, bond pair is equal to 4 means it is sp3. Am I right? So we have very easily calculated this hybridization, and since there is no lone pair, so its shape will be regular. Now let us take example of this nitrogen. Nitrogen is 2, 5. Am I right? So valence electron is 5 plus 1 hydrogen should be always 7. 7 4 ja 28, and plus 1 means minus 1. So how much you have getting? 33 minus 1 is equal to 32. 2 divided by 8, again you are getting 4. No lone pair is there, it is bond pair, so no distortion is there, you are getting sp3, 3 and 1 4. Again its tetrahedral bond angle is this, it is sp3 hybridized. Let us take example of PH4 plus, so nitrogen phosphorus means it is also 5 and H means 7 minus 1, 33 minus 1, it is 32 divided by 8 is equal to 4. No remainder, no lone pair means it is sp3 hybridized, its shape is regular. Am I right? In this way, you can calculate each and every one by this method. You will find whether there is lone pair. If there is lone pair, one lone pair, it is less than 109. If it is two lone pair, it is 104 around. And if it is 1, it is pyramidal, and if it is 2, it is band shape. It is trigonal, pyramidal, and bonding. Sorry, planar. Bond angle is 120. If there is no lone pair, pair is equal to 1, bond angle is equal to less than 120, and shape will be B shape or band shape. This is simple information. So let us take one example. And lots of other examples here that I have chosen out this much. CO3 2 negative, CH3 positive, benzene, LCl3, BF3, NO2, NSO3. Let us take anyone randomly. That's C. Say carbonate. The electronic configurations of carbon, the valence electron is equal to 4. Am I right? Valence electron is equal to 4. So 4. And here valence electron is equal to how much? 6. So 6 3 is 18. Minus means plus 2. So you are getting 24. Am I right? So no remainder is there means 3 bond pair is there. If it is 3, so S will remain 1, and to make it 3 unit, it is sp2 hybridized. So the bond angle will be 120 and it is trigonal, planar. So one example regular I have taken, and let us take this one. Very often in exam it is asked. Let us take this one. Nitrogen, this is 5 plus oxygen. How much oxygen? Is equal to valence electron equal to 6, 6 to 12, minus 1 is equal to plus 1, 13 is equal to 18, 18 divided by 8 is equal to 2, plus 2 electron as remainder, so 2 bond pair plus 2 electron is equal to 1 lone pair. Total is equal to 3, 3 means sp, s is fixed, to make 3 we need sp2. So again NO2 is sp2, but I told you, if lone pair is equal to 1, this is only one case is there only one case. Lone pair is 1, so the bond angle is less than 120, and this is band shape. Its shape is band shape. It is no longer 120, no longer triangular planar. And you can take example CH3. I have already told you. This is plus 1 bond, 2 bond, 3 bond. 3 bond plus is not 3 bond is equal to this, it is sp2. Or by this method we have calculated. If you want to calculate in this way also you can. So carbon is what? Carbon is what? 4. How many hydrogen? 3 hydrogen. One hydrogen is to be assumed as 7 electron. So it is 3 7 ja 21 is equal to 25 divided by 8 equal to 3 4 ja plus 1 hydrogen equal to 7 means 21, and there should be 1 minus. Plus means minus. So how much you are getting? 4. So it is 3. So bond pair is 3. 3 means S is fixed, to make it 3 we need sp2. Whatever way you take, you will get the result of hybridization is same. So this is all about sp. Now come to, sorry, sp2. Now come to sp. Take this one. So the carbon is equal to, it is 2 4, am I right? Valence equal to 4, oxygen equal to 6, 6 2 is equal to 12, 12 equal to 16. So you divide it by 2. No remainder is there, no lone pair is there, that is equal to s. To make is, we need p to make it to 1 and 2. This is sp. Hybridization is 100, it is linear. So let us take, this is bf2. So this is beryllium, it is 2, fluorine 7, 14, it is how much? 16 divided by 8 is equal to 2, means 2 bond pair, it is sp. Am I right? So in this way you yourself can assume, calculate the hybridization in this way. So hybridization is a must, and whenever you find a hybridization and lone pair, is a must to get its shape. Now in the midway I am telling what is isostructural. If hybridization is same, say two structure, three structures, you are asked to find out which two structures are isostructural, then hybridization should be same, number one. And if it is same, that may not be isostructural. Say it is methane, it is both has sp3 hybridization. So hybridization same means isostructural. It is not so. Hybridization same, lone pair also same. Here there is no lone pair, but a bit earlier we had seen there is two lone pair. So these two are not isostructural. But if you see CH4 and NH4 positive, then you calculate, you will find there is no lone pair, there is also no lone pair, and this is sp3 and this is sp3. So two structures are called isostructural if their hybridization is same and lone pairs are also same. So lone pair is very essential to know. So here also 4 lone pair, bond pair, or bond pair should be 4. Then it is hybridization. So is it not equal to sp3? But don't be confused. Here also 3 and 1 equal to 4. Don't be confused. This type is only present in case of coordination compound. So tetramine copper 2. This is a coordination compound. You will get it coordination chapter, higher secondary, second year. So only that type of compound are having dsp2, though they have also 4 bond pair plus lone pair equal to 4, same as sp3 is equal to bond pair plus lone pair should be 4. But don't confuse, this complex compound very often least appears in your exam. Always this should be sp3. Critical case there may be sp2. If there is sp2, then you need to find out a lot of things, coordination number, this and this, you will get in second year. So don't be confused with dsp2 with sp3. Your answer always will be sp3, and if you see there is any complex, then you try and fix whether it is sp3 or dsp2. So sp3 d 1, 3 and 4, so it is total 5, that is 1, 3 and 4, 5, am I right? So bond pair plus lone pair must be equal to 5. This is the structure of sp3d. Geometry is trigonal bipyramidal. Trigonal 1, 2, 3 trigonal bipyramidal. This is trigonal bipyramidal structure. If there is no lone pair, am I right? If there is any lone pair, then the shape will change, angle will change. So let us take one or two, any example. Let us take this one. I think it is regular. So nitrogen phosphorus. Nitrogen phosphorus means 5. It has 5, and chlorine has 7. 7, 5, 35. So 35 is equal to 40. 40 divided by 8 is equal to 5. You are getting 5. No lone pair is there. Remainder is there, means 5. 5 means lone pair, bond pair is 0. You are getting 5 means It is sp3 hybridized. Let us take this one. P is 5. Oxygen, fluorine is last electron 7, 7, 5 is 35. Again it is 40. 40 means 40 divided by 8 is equal to 5. 5 is equal to sp3 D. 3, 4, 5. So you test all other, each and every one you will get first line, no lone pair, regular structure. It is trigonal, bipyramidal. It is regular structure. Now let us take example of 4. You must know this group. Non-metal groups, that is P block, you should know. Am I? You please know this group. 13, 14, 15, 13, 14, 15, you please learn by heart. So if it is tellurium means it is in oxygen group. Am I right? So last electron is equal to 6. Am I right? Chlorine is equal to 7. Chlorine is equal to 7. So 7, 4. So how much you are getting? 34. So divided by 8. So 4. You are getting 4 plus twice electron. 4 means 4 bond pair and twice electron means 1 lone pair. This is the example where bond pair is equal to 3 and lone pair is equal to, bond pair is equal to 4 and lone pair is equal to 1. 4 and 1 is equal to 5. 3, 4, 5. Am I right? No doubt it's tellurium tetrachloride is second type of example where lone pair is equal to 1 and bond pair is equal to 4. Total is 4 and 1, 5. 5 is equal to sp3d. It is whether the structure is regular. No, its structure is irregular, pentagonal, irregular, trigonal, bipyramidal. Irregular because of presence of one lone pair of electron. Am I right? Now let us take another example. This is very, very important in IIT, in JEE and NET. This type of question very often comes. I3 negative. Am I right? So fluorine, chlorine, bromine, iodine means 7, last 7. How much? 7, 7, 3. 3, 7 is how much? 21. And 1 minus means 1. You are getting 22 divided by 8. 16. 6 electron remaining. So your remainder is 6 electron. Result is 2. Am I right? So you are getting 2 bond. Minus to follow this one. 2 bond pair plus 3 lone pair. 6 electron equal to 3 lone pair. Total is 3 to 5 is equal to 5. This is equal to hybridization is no matter sp3d, but the question of shape, because I am concerned with the shape. Now what's happened? I told you, if there is lone pair is equal to 1, then it is irregular, and if lone pair is equal to 3, it will be linear. Mind them, it will be linear. So its structure is equal to, it is sp3d and it is linear. It has 3 lone pair and 2 bond pair. Come to this one is left. Am I right? So let us come to the middle part. Let us take this example, ClF3. So fluorine, chlorine, bromine means 7. Am I right? 7. And 1 fluorine is equal to again 7. Am I right? 7 plus 7, 3 is 21. You are getting 28 divided by 8. 24. 4 electron. Am I right? So you are getting 3 bond pair plus 4 electron is equal to 2 lone pair. Total you are getting 5, means no doubt your hybridization is 5. Am I right? 3, 1, 4, 5, sp3d, no doubt. But due to the presence of 2 lone pair, structure is T shape. Structure is T shape. So one thing, let me write, if lone pair is equal to 1 for this, very important, very often asked in the entrance exam, mind that lone pair is equal to 1, it is irregular trigonal bipyramidal. If lone pair is equal to 2, this is T shape, and if lone pair is equal to 3, then it is linear. You may not imagine. Example is this, or xenon difluoride, very often asked in the question. This time xenon, this was how many lone pairs are there in the NEET exam, how many you calculate the lone pair. So xenon means what? Xenon means fluorine, chlorine, bromine. It is next in 18 group. Am I right? 18 group. So this is last electron is 8 and it is last electron is 7. 7 to the how much? 7 to the 14. So how much you are getting? 22. Am I right? So 28 divided by this, how much? 82 equal to 6 electron left. So 2 result is equal to bond pair, and 6 electron means 3 lone pair. Again, this is the case of I3 negative. Am I right? 3 lone pair means linear. Again, XCF2 is also linear pair. 3 lone pairs are there. So determining factor is the lone pair. If you don't know lone pair, you can't tell about the isostructure of the 2 or 3 molecules. If the lone pair hybridization is same, but if lone pair is can't find out, then it's not possible for you to answer whether it is isostructure or not. And if it is if there is lone pair, then regular structure, I have told you the first regular shape you should know, you should learn. And if there is 1 lone pair, if there is 2 lone pair, if there is 3 lone pair, so the shape differences: irregular trigonal bipyramidal, T shape, and linear shape. There are 3 possibilities, and 3 possibilities asked in the entrance. So this is in sequential order. You try out, you can find out this one. So next one is examples, and this is sp3d2 means 6 lone pair and bond pair must be equal to 6. If there is no lone pair, then it is octahedral. If there is no lone pair, it is octahedral, and if there is lone pair, there is change in shape. So there is 2 possibilities: lone pair 1 and lone pair 2. If lone pair is equal to 1, it is square pyramidal. From octahedral, it will come to square pyramidal. And if it is 2 lone pair, then this octahedral structure will come to square planar. So square pyramidal and square planar if there is 1 lone pair, and if there is no lone pair, it is octahedral. Let us try with this one: sulfur, oxygen, sulfur, sodium, tellurium. Means it is oxygen, group oxygen, means it is 6. Here it is equal to fluorine, chlorine, bromine, argon. 7, 6, 42. So how much you are getting? 48. So you divided by 8, how much you are getting? 6. Am I right? So no remainder is there, no lone question of lone pair is there. Means it is 6. If it is 6, this is sp3d2, 3 to 5 and 1, 6. We have balanced it. So it is octahedral, lone pair is equal to 0. The first case is over. Now ICl5. I is what? 7. Cl first 7. 7 5 what? 35. How much you are getting? 32. Divided by 8 equal to how much? This is this. This is 5. 5 is the 40. Remaining 2 electrons. So this is 5 bond pair and 1 lone pair. So this is the case. 1 lone pair, square pyramidal. The shape is, hybridization is nothing but sp3d2. Hybridization is nothing but sp3d2, but the structure is square pyramidal. Lone pair 1 square. Only 2 cases there. Don't get confused and nervous. Now come to this one. Xenon. Helium, neon, argon, krypton, radon. Xenon, it is 18 group. So last electron is how much? Last electron is 8. Here last electron is 7. 7 4 the 28. How much you are getting? 36. Divided by 8 is equal to what? How much? 4 electron left. So remainder your result is what? Bond pair, and remainder is equal to 4 electron is equal to 2 lone pair. So 4 2 is equal to 6. 6 means sp3 d2. No doubt hybridization is this. Now if you want to tell something about is configuration, so sorry, shape, lp lone pair is equal to 2, it is square planar. So it is square planar. Only 2 cases there in sp3 d2, nothing more. Final first structure you should know. If there is lone pair, there will be some distortion. Let us check with this one. Only 2 cases is there. Mind that. Again, you should not be afraid of this thing. This is how much you should know. No, only 2 cases there. One is regular case, another is one lone pair. Nothing more. Here sp3d2. Say iodine is equal to 7 and fluorine is equal to last electron 7. 7 7 ja 49. This is equal to 56 divided by 8. This is 7. So all are bond pair. Lone pair is not there. If it is 7, so this is sp3 d3. So it is pentagonal bipyramidal shape. IF7 doesn't have any lone pair. Now let us check with this one whether there is any lone pair or not. So xenon, what is xenon? It is 8 and it is 7. It is 42. You are getting 50. 50 divided by 8. 8 divided by 6. 2 electron left. 2 electron left. So this is 6 bond pair. 2 electron is equal to 1 lone pair. So one case is there, 1 lone pair, means its hybridization is nothing but sp3d3, because total is 7. Am I right? 7 to get 7, 3 3 3 1 and 7, and it is fit to this formula. So its hybridization is sp3d3. But question is, what is the shape? What is the shape? Shape is nothing. Will never be pentagonal bipyramidal, because there is one lone pair of electron. It is distorted structure. Am I right? So this is all about our today's structure. We have discussed how to predict the hybridizations in organic compound and also inorganic compounds, and also ions and cations and anions. And also with the help of this we can tell the shape, and also with the help of this we can tell which structure is isostructure and not. Thanks a lot for watching the class, and don't forget to subscribe the class if you find it valuable. In the next class I will start with hybridization. I will not discuss hybridization, but bonding, variation of bonding, and